Hello everyone, my name is Hemu and today's we are here for the first day of your Palo Alto Firewall session. Okay. Now before starting the actual session, let me just tell you some details. So guys, if you will see my screen, this is my contact number. So for any type of questions, any type of issues, you can able to reach out to me on this number. WhatsApp is also there. So if somebody from the international, some like international students, they can able to reach out to me on WhatsApp as well. And guys, over the big days, basically, over the big days, I'm available between 12 p.m. to 1 p.m. IST. So during this time, what you can do, you can basically reach out to me. You can able to call me and you will get the response. Sometime because I was also busy with my office work. So sometime you will not get the response like right away, but definitely you will get the response. So in WhatsApp, you can able to text me anytime. Whenever I used to get time, I used to respond. Okay. But this is the time which I have provided for my students' queries only. Okay. This is the one thing. Now for the international students, what they can do, they can able to reach me at 9 p.m. IST as well, because during this time it's night there. So you guys needs to reach out to me on this particular time. This is my email ID for any type of, like if you want to share anything, this is my email ID. So you can able to share the details with me. This is my LinkedIn profile. And the most important part, guys, this like all the recordings you will get through our video portal basically. And guys, for Android users, what you can able to download our application, and this is the link for that. For iPhone users, you have to basically go into this particular link and you have to enter the organization code, which is VNCPH. You can also able to access your recording with the laptop, and this is the link to access the course through laptop, and this is the organization code VNCPH. And guys, just remember one thing, you can able to access our courses from one mobile phone and from one laptop. Do not try to log in with the same credential into multiple mobiles or multiple laptops, because there is a system binding with the browser. System and browser binding will be there. Okay, so you will not able to log in. So these are the things which you need to basically take care at your end. Now, let me just tell you what are the topics which I am going to cover in your today's class. So today we are going to discuss like what is firewall. Then we will discuss what is stateful inspection, Palo Alto firewall history, or how Palo Alto organization is started, Palo Alto operating system, PAN-OS, Palo Alto hardware model, and Palo Alto VM series devices or virtual appliance. We will also discuss the most important topic, which is SP3, single pass software and parallel processing hardware, because in every interview they are going to ask this question. Can you just explain SP3 architecture? And after that, I'll just explain you the packet flow or life of a packet in your PAN-OS. Then we will discuss how we can take the initial access of your device. What are the ways we will be having to get the initial access of your Palo Alto firewall? So these are the topics, guys, which I'm going to cover in today's class. So let me start with this particular term called what is firewall, because there are lots of students who is from some other background. So maybe they are not aware about this particular term, what is firewall. So if I'll say firewall is a security system, or firewall is a security device which controls the incoming and outgoing traffic, or which controls the incoming and outgoing request. Now let's try to understand what is incoming and what is outgoing request. So what I can do, let me just draw one diagram for that. So let's suppose I will draw a typical typical diagram for an organization. So I have a firewall. I have a core switch. I have a access layer switches here. Or let me just go with little bit simple design. Let me not make this too much complex. So I have a core switch here, or I have just a switch, and let's say I have one PC here. This PC have a connectivity through this switch with this firewall, and this firewall have a connectivity with the internet service provider, which is ISP. And this ISP have a connectivity with the other part of the internet. So let's suppose in internet we have a website called google.com. We have a website called facebook.com. And we have a let's say website called gmail.com. And these are the servers where Google, Facebook, and Gmail is hosted. Now, as I have mentioned, let's suppose this particular interface of your firewall is Ethernet 1x1, and it's a part of outside zone. What is outside zone? I'm going to cover in some time. Okay. And we have another interface Ethernet 1x2, which is your inside zone, part of your inside zone. Okay. Now, guys, just tell me one thing. In a production environment, what is the name of this particular area? What generally we used to what type of name we used to give to this particular area? This is your LAN, local area network, or this is your trusted area, right? This is your internal, we can say internal network, or also we can call it, right? So means this part is known as LAN. And guys, here generally what type of devices we will be having? In this area we will be having your employees' computers. Whatever employees is working for the organization, they used to connect their devices here. Whatever the internal servers you are having, all these servers will also present in this particular area. And this area is known as local area network, LAN. What is the name of this particular area, guys, generally? When? Wide area network. Because you know, this part is you don't have any control. You have any, you can able to control anything at your ISP end. Are you able to control any router or any device of internal service provider? No. Are you able to control the googles.com or facebook.com? You don't have anything, right? Which means this is a wide area network. Now, what this firewall used to do, because you know this is your internal LAN, right? This is your internal LAN. So what, as I have mentioned, firewall is a device who can control the incoming and outgoing request. So the meaning of outgoing is the traffic which is going out from your organization boundary. Means whatever traffic is going out, because you know this particular employee, he will try to access google.com or facebook.com or gmail.com. So what used to happen? His request is going outside of your organization, right? And let's suppose let me just add few more points here. Let's suppose you have here one more server as well. This is your internal server. And you have hosted the website of your organization into that server. Now, there is a one user over the internet. This is the user over the internet. And what that user wants, he just wanted to access, he just wanted to know about your organization. Let's suppose your organization name is abc.com and he just wanted to know regarding this abc.com. So what will happen? This user will open his web browser and he will type abc.com. And when he will type this abc.com, his request will come to your firewall, and firewall will forward this request towards your internal server, right? So means if you will see this request, this type of traffic coming inside your organization, right? Means this traffic is known as incoming traffic. This is known as incoming traffic. And when we have let's suppose this people, when he has opened the google.com in his web browser, that request is going out till here. It is leaving your organization boundary. This request is known as outgoing request, or this traffic is known as outgoing traffic, and that traffic which is coming inside is known as incoming traffic. And what this firewall is doing, he will basically control the incoming and outgoing traffic. What do you understand with the control? Control means how he will control. Either he can allow something or either he can deny something, right? That is only controlling, right? Means if request is legitimate, he will allow. If request is illegal or request having some malicious content, he will deny it, right? So guys, now you will understand the do you mean by the incoming traffic, outgoing traffic, and the control. So firewall is a device who will control incoming and outgoing traffic. Now, there is one more thing you need to understand here. Guys, let's suppose from this PC, I have initiated a request towards google.com. So that traffic is received by the firewall on Ethernet 1x2 interface. And that traffic is exit out through Ethernet 1x1 interface. That's true, right? So guys, this interface become the ingress interface. Ingress interface is an interface which receives the traffic, and this interface become the egress interface. Why I'm mentioning this ingress and egress? Because you know these are the terms which I'm using a lot in your future classes, in your future sessions. So guys, this ingress and egress is clear. Ingress is an interface which receives the traffic, means you are going inside the firewall, and when you are leaving the firewall, you have to leave through one of the interface or one of the port, right? That port become the egress interface. Now, so guys, this device called firewall, this is a firewall is a security system or a device who can control incoming and outgoing traffic on the basis of layer 3 information, layer 4 information, and layer 7 information. Guys, do you have any idea about what we have at layer 3, what we have at layer 4, and what we have at layer 7? Anyone know what is TCP IP model? TCP IP model. Let me just get a copy of it. Okay, this picture is not clear, right? Let me just take another one from the internet. This looks good. Let me just try with that. Guys, this image is visible. Wait for a minute. I used to have one. Okay, now I hope it is visible to everyone, right? Are you able to see all these layers and other things? Just confirm. Cool. So guys, generally what used to happen, like why, anyone have any idea why this TCP and IP model came in a picture? Let me just give you some brief of it because it's a CCNA level topic. But let me just give you the idea. What used to happen, guys? Let's suppose we have one person. He is from Russia. And we have one more person. Let's suppose he is from India. Now this person who is from India, he know Hindi. And that there's a one person, he is from Russia, he know Russian. Now just tell me one thing. Are these two people, if they want to communicate with each other, are they able to communicate? Because Russian people, he is basically speaking Russian language, and India people, he just, or Indian people, he is speaking Hindi. And this Russian, he don't know Hindi. And even though Indian, he don't know Russian. So are these two people able to communicate? Yes, no, on the chat. They are not able to communicate, right? Now let's suppose we have one third person. This is the third person. Now this third person know Russian, and this third person also know Hindi. And but guys, this Indian people, he know English. He can able to understand English. And this Russian, oh, let me go in this way. Just give me, let me just go in this way. Now, what is happening? Because you know, this third person, he know Hindi and he know Russian. So what they used to do, this Russian person is basically conveying his message to this third person, and this third person converting his message into the Hindi to this particular Indian person, and Indian person is sending his details in Hindi language to this third person, and third person will talking to, and this third person will explaining that same information in Russian language to Russian people. Means now here, what is the point of contact? We have this third person, right? So what used to happen, guys? This was the case which is applied in your computers as well. Because you know what used to happen? Let's suppose there were few companies like HP. We have a one company called IBM. We have a one company called Dell, right? These are the main companies who used to basically manufacture the devices or laptop, right? Or we have some other companies also, like which used to also make the router switches, like any type of networking devices. Now, what used to happen, like when journey of these computers is started, there were only the few companies who is making these particular devices. So what they used to do, this IBM computer, the computer which is manufactured with the IBM, he can only able to communicate with the another IBM computer, because you know they have his own standards to create the IP stack. And Dell company laptop only able to communicate with the Dell computer, because they have their own rules and standards to create the IP stack. And same thing is applied to HP. HP computers, they have his own rule and standards to basically manufacture and to create the IP stack. And so the thing is, what used to happen, let's suppose if an organization, he has 10 computers from IBM and he has 10 computers from Dell. And let's suppose these 10 computers from IBM wants to send any data to Dell computers, they cannot able to communicate. That was the issue faced by the peoples during that time. So what they did basically, they have created a model called OSI. And in this OSI model, they have divided this particular IP stack or communication over these 7 layers. We have an application layer, we have a presentation layer, session layer, transport, network layer, data link layer, and physical layer. So guys, your transport layer is a layer 4, your network layer is a layer 3, and your application layer is a layer 7. And guys, all this particular OSI model, it has just written the some rules and standard to manufacture the or to create the IP stack. And guys, they have just enforced all the vendors, all the organization. Now every organization, they have to follow these particular same rule and standards to create the IP stack. And if they will follow the same rules and standards to create their devices, means now these devices can able to communicate with each other. So now guys, you got the idea why we have the OSI model in the picture. That is the main reason behind this OSI model. OSI model is nothing, it just have a set of rules and standards which every organization needs to follow when they will manufacture their devices. And guys, this OSI model is just a reference model for creating the IP stack. And after that, the actual implementation of this OSI model is your TCP IP model. In TCP IP model, we have a layer 4, we have a layer 3, and this is your layer 7. Okay, so now guys, what used to happen? We have this computer. Generally, in every organ, your networking world, guys, this computer will have some IP address. Let's say it has IP which is 10.1.1.70. And let's suppose it is trying to communicate with google.com. Let's suppose google.com IP address is 8.8.8. And google.com, because you know it's a HTTPS website, so this website hosted over TCP 443. So guys, your HTTPS website hosted on which port number generally? It is in 443 only, right? Most of the time. Now, what used to happen, guys, when this PC will send any request towards google.com? So what will happen? This google.com, this PC will create a packet like that. In this packet, he will put the IP address 10.1.1.70. This is the source IP address, and destination IP address is 8.8.8.8. Source port it will put. Let's say it has taking the source port which is 1025, and destination port is 443. And after that, here you have some layer 7 data. This is the packet, right? Now, in this packet, if you will see this information is your layer 3 information. This information is your layer 4 information, and this information is your layer 7 information. Okay. Now, what this firewall used to do, because it used to understand the source IP address, destination IP address, source port, destination port, means now if this firewall wants to control the traffic, means if my firewall wants to allow that traffic or deny this traffic, what it will check? It will look this source IP address, destination IP address, source port, and destination port, and according to these particular details, it will make the decision. Means in this firewall, we have to configure the access control list, I can say, or the security policies. We have to configure the access control list, or we have to configure the security policies, where we will mention if traffic coming from this PC and going towards google.com, you can allow it. If traffic coming from this PC and going towards gmail.com, you can deny it. These type of rule set we can able to create. on this firewall, then only this firewall will take the action. So guys, now you got the point here, how my firewall used to control the traffic. So firewall is a device who can control the traffic, means he will control on the basis of layer 3 information and layer 4 information. Layer 3 information means source IP, destination IP. Layer 4 information means source port and destination port. Apart from controlling, it will also do the inspection. What? Firewall is a device who can control the traffic and who can inspect the traffic. So guys, this inspection come for your layer 7 information, means my firewall can check the layer 7 data, check the layer 7 payload, and it will basically provide you the inspection. It needs to inspect the data for any type of malicious content. If there is any malicious content, it will block the traffic, or if there is any, if there is no malicious traffic, then it will allow the traffic. Liaquat has asked one question, like it's a very good question. Can be able to block the traffic on the basis of MAC address instead of IP? So Liaquat, like firewall is a layer 3 device. Okay. So it can able to protect you from by using the layer 3, layer 4 and layer 7 information. Okay. If you will deploy your firewall in layer 2 mode, in that time only you can able to control. And also Liaquat, your layer 2 information is unique hop by hop. Like if this PC till this PC till this way, your layer 2 communication is there, right? Your layer, your MAC address will change hop by hop. Okay, so we cannot, we never control the traffic on the basis of MAC address and other things. Okay. Now let me come. So guys, this device called firewall, you can see it is a hardware appliance. Sometime you can see this device, it can be a virtual device as well, VM appliance. And this device can also be a application or any type of software. Means your firewall is available into three forms. It can be a hardware box, it can be a virtual box which you have installed in any type of hypervisor environment like your VMware, your OpenStack, right? Anywhere. And it may be any type of application or software. So we have a this device you will see into all these three forms: hardware, virtual and application. Guys, the example of this application or software based firewall, like you can able to create a firewall rules in your Windows PCs as well, right? We have some Windows Defender type of softwares, right? These are the example of software firewalls. Like your Palo Alto, your Cisco ASA, all these are the hardware based firewall. But for Palo Alto, VM is also available. For Cisco, VM is also available. So guys, I hope everyone is clear with the definition of firewall. Now, guys, in the environment, or nowadays, if I will mention the name of few popular firewall vendors. So guys, nowadays we have a two type of firewalls. So guys, what used to nowadays we have a two type of firewall. We have a next generation firewalls and we have a legacy firewalls. Now, this next generation firewall, in this list, we have a Palo Alto firewall. We have a FortiGate firewall. We have a Checkpoint firewall. And we have a Cisco FTD FMC. These are the popular next generation firewall. Apart from these firewall, we have some legacy firewall as well. If I'll say the name of legacy firewall, we have a Cisco ASA, most popular legacy firewall, and it is a most used firewall. Then we have a Juniper SRX. Juniper SRX is also used by the peoples a lot. Then we have a Sophos. We have a Cyber Roam. And let me put like others. We do have some other firewall from Dell, from HP. Like there are multiple organization. They do have some firewalls. Now, what is the major difference between legacy firewall and your next generation firewall? So if I'll say the major difference, your next generation firewall can able to protect the traffic on the basis of layer 3 information, on the basis of layer 4 information, and on the basis of layer 7 information. And your legacy firewall can only able to protect using the layer 3 information and using the layer 4 information. They don't provide the protection at layer 7. And guys, nowadays all type of malicious attack used to happen on the basis of layer 7 information. So guys, this is the major difference between next generation firewall and legacy firewall. And because guys, your next generation firewall able to inspect the traffic till layer 7, which means they offer some very cool features like application identification. The very first feature which is offered by the next generation firewall, which is app ID, meaning in your next generation firewall you can able to create the security policies, or you can able to control the traffic, you can able to allow and deny the traffic on the basis of applications. On the basis of application you can able to control the traffic. Because just tell me one thing guys, there is a very popular application called torrent, and I can say whatever IP address we have for torrent, IP address of torrent and the port number of torrent, these two value is not fixed. These value is dynamic for torrent servers. These values they used to change. Now can you able to block the traffic using these legacy firewall for this torrent application? Guys, are you able to block that traffic? Are you able to control the traffic for torrent using these legacy application, using these legacy firewalls? No, right? And I got there is a one question from the other person. What is Faraz, right? Faraz has asked, sir, this layer 7 feature is available only in Palo Alto and other firewalls. So guy, so like Faraz, like your next generation firewall, Palo Alto, FortiGate, Checkpoint, and Cisco FTD FMC, they all supports these layer 7 inspection. Okay. Now, so guys, in AppID, we will discuss more in your future classes. So what used to happen nowadays, you can able to control the traffic on the basis of app ID in these next generation firewall. Means this torrent traffic you cannot able to control using this legacy firewall, because the layer 3 and layer 4 information is not fixed here. But guys, can you able to tell this torrent website, whatever website or application they are having, the code of that particular website is fixed, right? It has some fixed pattern. And your next generation firewall, they used to basically detect this traffic is a torrent traffic with their application engine by looking into this particular code basically, or the program, because that particular torrent has some specific, some defined pattern, and these firewall, they will basically get the details of that application from that particular code or particular program. Okay, because that they cannot able to modify the layer 7 information every day, right? These IPs they can change, but actual code they cannot able to program. It's very hard to program that particular code. Okay, now apart from that, this app ID will also help you. Like what you can do, let's suppose you want to allow the Facebook, but on this Facebook you want to block the Facebook chat, or you want to block the Facebook post. These type of control you will get with the traffic using this app ID feature. So this is the one of the biggest features supported by all your next generation firewall. Then we have a second most important feature, which is URL filtering. Means these next generation firewall, you can able to basically allow the traffic and block the traffic on the basis of URLs and on the basis of URI. And also one more thing, like these next generation firewall, they will provide you the category of URL. Let's suppose you want to block all the pornography website. You can able to do just in one shot, because they have created the categories for the URLs, and that particular management of these categories, the responsibility of that particular vendors. There are the team of peoples who is basically doing all these particular tasks every day. Let's suppose you want to block all the social networking website. You can able to block with the help of URL category. Means you will get this particular feature as well in your next generation firewalls, URL filtering. And Abu, like your legacy firewall, they will not support the URL filtering. Okay, you have to add some extra module. Like if you want to implement URL filtering on Cisco ASA, you have to install the CX module, which is a dedicated hardware for URL filtering. Okay. Now, apart from that URL filtering, now these particular firewalls, they have a feature called antivirus protection. Means generally what used to happen, let's suppose we have this PC, we have a firewall, and there is a one server. We are trying to download one file from that server. Now let's suppose when we are downloading this particular file from that server, now that file have some malicious code. There is some malicious code, or that particular file have some type of virus code. So guys, tell me one thing. This particular virus code is available at layer 3 or layer 4, or it is available at layer 7? At which layer that particular information is available? It is a part of layer 7, right? Which means, is your legacy firewall able to provide you the protection from virus? They cannot able to inspect layer 7 content. Means by using these particular next generation firewall, because they can able to inspect the layer 7 content, and they have the dedicated engine or dedicated chip who will basically provide the protection from these type of malicious code. So means this antivirus features is also available in your next generation firewalls. Then we have a next feature, which is anti-spyware. Anti-spyware protection also you will get into these next generation firewalls only. Then we have a one more feature called vulnerability protection. Vulnerability protection is also comes under the layer 7. Vulnerability protection means, let's suppose there is a system, that system have some weaknesses, and hacker used to exploit these particular weaknesses, and it will try to get the unauthorized access of that particular system. Okay. And if somebody is trying to exploit that particular vulnerability, they will exploit with the help of layer 7 information only. And because these files, they have a visibility at layer 7, so they will provide you the vulnerability protection. Gaurav, antivirus is nothing like anti-spyware and nothing. Spyware is some type of malicious code whose main intention to just collect the information and will basically upload that information to the hacker system. This is just a code who will collect the system information and it will send that information to the hacker system. Now, we have one more feature called file protection. By using these next generation firewall, you can able to write the security policies. You can allow the upload and downloading of different file types. Let's suppose you want to put some protection, like people is not able to download any type of exe file. They will not able to download any type of bat file. Let's suppose you can just put some protection, like people is not able to upload any type of PDF files. They are not able to upload any type of Visio files. They are not able to upload any type of any other type of files, like any type of Office documents and other thing like Word document and Excel file. These type of protection also you can able to configure in your next generation firewall. And like I'm just writing one more specific topic with regards to the Palo Alto only. There is a one feature called wildfire. This wildfire feature protects us from the unknown malware and threats. What do you mean by the unknown malware and threat? Let's suppose there is a one hacker community. There is a hacker community. It's a community of some hackers. They have created one malicious code, or they have created one malware. And this malware information is not aware of, like there is no vendor who has the information of this particular malware, because it's just a pretty new malware. It's just a pretty new malware. And if let's say this malware they have added into one of the email, and that email, let's say they have forwarded towards a user, and that user sit behind a next generation firewall. So what will happen? That next generation firewall stop that particular malware, or stop that particular email or that particular specific code, and will try to upload that particular code towards the wildfire cloud. And on that cloud, they will basically run this particular malware into different type of systems. And they will observe the behavior. If behavior is like malware, they will basically create a signature and update that signature towards all the machine, and they will also inform the firewall right away. This is a malware. You can basically block that particular traffic. So that these are the some feature which I have written, which is only available in your next generation firewall. So guys, if somebody asking in the interview, what is the main difference between legacy firewall and next generation firewall? I hope, are you guys able to answer? And Abu, like, because you know, these firewall, they have some predefined signature database. Okay, these things I will cover in your future sessions. Okay, it has a predefined signature database, and it will match that particular database for all these particular threats and other things. That's how they will use to detect is it is a malicious traffic or not. And we have to enable all these protection. Okay, so you don't worry about the protection. Without applying this protection, we cannot able to control the things, and we are not able to protect like layer 7. We cannot able to protect from malware, antiviruses and other things on your legacy firewall. That is the main reason people are moving towards the next generation firewalls. Okay, cool. Now let me explain you one more thing, guys. We have this particular device called firewall. We have your local area network. So guys, this area is generally known as inside. It is also known as trust zone. So means this area is always known as inside zone, or either it is known as trust zone. Because you know here we have our employees, right? And we have a full trust on our employees, because whatever systems is used by these employees, the system is configured according to our organization policies. They have the necessary antivirus systems and other things basically. So we have a full trust, and the area where we will put these particular peoples in your network is known as inside area or is known as trust zone. And the firewall, because you know this device will connect you with the internet service or with the internet. This particular part is known as outside zone, or this interface we will put in outside zone, or either we will put this interface on the untrust zone. And guys, always in most of the time, firewall we used to put at the perimeter of your organization or at the edge of your organization. Means generally we will provide the direct internet connection into your firewall. Like if you will see this diagram, this is the typical deployment of an firewall. Like what we have a access switches. So this is your access layer, and below this access layer we have your end users, where we have your employees computers and your servers. And these access switch, they have a connectivity with the distribution switches. This is your distribution layer. And after that we have a core layer. Here we have your core router. Generally this is your layer 3 device like router, or either it's a layer 3 switch. So we have a core router, we have a core switch, then we have a firewall. So generally firewall is a layer 3 device, and we used to put at the perimeter, and after that you can see these are your internet or ISP service provider routers, and from here you will get the internet connection. Perimeter means edge of your network. Okay, so generally we used to keep the firewalls into edge of your network, and these type of firewall is known as a DIA, direct internet access device, because these are the firewalls who will basically provide you the direct internet access to your users. Okay. And if you will see in this particular design, we have the same thing. We have your layer 3 switch, then we have your access switch, and here we have your employee computers. We do have some wireless infrastructure. So these are the access point, and we have your mobile phone and PCs. They are connected with the wireless. And after that, we have your firewall, and firewall has a direct connectivity with the internet service provider. So this is the perimeter. This is the perimeter or edge of your network. And firewall, what firewall used to do, it will basically block the, it will allow the traffic and it will block the traffic. Means it will allow the legitimate request and it will block the malicious request. Now one more thing you guys needs to know before moving further. Let's suppose I have this firewall. This is the device. Sometime what used to happen, generally what used to happen, we have these type of interfaces on your firewall. Let's say this interface Ethernet 1x1, this interface Ethernet 1x2, this interface Ethernet 1x3, and this interface is the management interface of your firewall. So guys, this Ethernet 1x1, let's say it has a connectivity with the internet service provider ISP. This interface is a part of inside zone, and here you have your employee computers. This interface we will always put in the outside zone because this interface connecting us with the internet. And after that we have a management interface, and that interface will take care of the management part, means whatever configuration you want to take. So you will did the configure on this device. You have to take the access of this firewall through the management interface in most of the time. And after that we have this Ethernet 1x3 interface. This is a DMZ interface. What is DMZ? DMZ stand for demilitarized zone. In this particular DMZ, generally we used to keep our servers. What? We used to keep here servers. What type of servers? They are the internet facing servers. What do you mean by the internet facing servers? Mean these are the generally web servers. Server 1, server 2, and server 3. These are the web servers. Now guys, tell me one thing. Let's suppose this particular we have this PC1. This PC1 belongs to a network engineer 1. Now let's suppose this particular organization is abc.com, and we have hosted this abc.com on these three servers. Now let's suppose we want to do some changes on this particular server and on this abc.com code. What they used to do, your network engineer, or let's suppose your developer, what he will log in into this server. He will make the changes on the code, right? And let's suppose we have one user as well here over the internet. Now this user wants to know about the abc.com. So what, he will open the web browser and he will try to access this abc.com. So that request came to your firewall, and firewall will forward this request over these servers. So guys, if you will see on your DMZ zone, this demilitarized zone, here request is coming from outside and also request is coming from inside. Both type of people is sending the request. Let's suppose over the internet, this particular PC is belongs to some hacker. And now let's suppose this hacker is try to exploit some information. He just try to install some type of malicious code on this server. And let's suppose your firewall, let's suppose for some time your firewall is not able to catch that particular malicious code, and he just installed this malicious code. Now what this malicious code will do, it will come, now this server is compromised. Now this malicious code, it will start spreading to these servers as well. And let's assume if these servers is available here in your inside zone, what will happen? Now your user's computer will also start compromising. So guys, that is the main reason your internet facing servers, we will always keep in a separate zone called demilitarized zone, DMZ. And here we always have the internet facing servers because of that reason only. If any of our server got compromised, your employee system, all, let's suppose these are the web servers, right? Maybe we will put here your database server because these are the actual server where we have the actual information, right? These servers we will always keep in your inside area. So if these servers got compromised, at least your database server is safe. So guys, always we will keep your internet facing servers in a separate zone called DMZ zone. So guys, the terminology which is inside, outside, DMZ is clear to everyone. Just confirm over the chat if this thing is clear to everyone. And guys, the terminology called like incoming, outgoing, ingress and egress is also clear. Cool. So Gaurav has just asked, just repeat this DMZ. So DMZ is a zone where we will have a internet facing servers, or where we have in most of the time web servers, because in web servers we will allow the traffic from the internet as well. Okay, so generally we will always keep your internet facing servers into this particular zone called DMZ. And if these servers got compromised, we have a protection, right? We can put firewall, we can put one more device called Wayfair, right? For adding some extra security. So that's how we will basically get the protection here. And we will keep keep your database servers or some internal servers or your employee computers in separate zone to avoid these type of issues if your DMZ is compromised, because you know, if DMZ is compromised and if that virus code is start spreading towards the inside, because firewall will not allow that traffic, it will block that traffic right away. It will not allow that particular traffic if traffic going from DMZ towards the inside. This traffic is blocked by the firewall. And even though if this hacker is trying to access any internal server directly, this traffic is also blocked by the firewall right away. Firewall will only allow the traffic it is going towards the DMZ for these specific servers, because these things we can able to control by configuring the security policy and other things. And guys, do not take like DMZ too much serious. You have to just remember DMZ is a zone where we have just internet facing servers, because I don't want to compromise my entire infrastructure. Because you know, DMZ is a zone where the request coming from outside and also request coming from the inside. Okay, that's it. Only you have to remember. Now guys, let me just start with the what is a stateful inspection, and I need your full attention here, because once we will complete your stateful inspection, it will also cover your firewall, Palo Alto firewall history. Okay. Now let's try to understand the stateful inspection. For that, I will draw one diagram. I have one of the PC here. I have the firewall. And let's say I have one server here, server one. I am just taking a very simple design here. I will not make a complex design. Now, what I can do, let me just go in this way, so you will understand more. Let's say instead of firewall, you have a router here, R1. And we have a server. On this server, let's say it's a web server. And that web server listening the request on TCP port 80. And on this web server, it has an IP address which is 10.2.2.101. And on this web server, let's say there's a file of 2 GB. Let's say this is a MP4 file and I'm trying to download this MP4 file on this PC. This PC have IP address which is 10.1.1.70. This is F0Y0 interface. This is F0Y1 interface. On this interface, I have the IP address which is 10.1.1.1. And here I have the IP address which is 150, not 150 series. It's 10.2.2.1. Okay, this is my LAN area, or this is my inside area, and this is my outside area, or DMZ, anything. Okay, I'm just taking these hypothetical things here. Now guys, tell me one thing. Now on this PC, what he is now trying to download this particular MP4 file from this server. So what he will do? He will try to make a connection with this server, right? So what he will do generally? What is the first request is initiated by this particular PC to that server? What is the first packet he will send when he will try to establish the connection? He had just this particular on this PC. Here we have just opened the web browser and we have just typed the IP address of that server directly. I got the answer. The first packet is TCP SYN, right? So he will send the first package, which is a TCP SYN request. And guys, because you know router is a stateless device, okay? First, I will going to explain you what is stateless concept, and after that, once you will understand the stateless concept, you will get the stateful concept. Now when this PC has initiated this TCP SYN request, what he will create a packet, right? So let's suppose he had created a packet like this. 10.1.1.70. This is the source IP address on this packet. Destination IP address is 10.2.2.101. Destination IP address. Then we have a source port. Let's say it will choose the source port randomly. 1025 it has chosen, let's suppose. Then we have a destination port, which is 80. Right? And generally TCP SYN is not having anything at application layer. Okay, just remember. Now this is the packet is created by this PC and this is the packet he will forward. Now when this TCP SYN request is received by the router, what this router will do? Anyone know what are the things this router needs to do with this packet? When this router receives this particular request, what it will do? It will start processing that particular packet. So what? It will process the packet at ingress stage. Ingress stage means because you know this when this packet received by this router on F0 by 0 interface, so what it will do? It will basically check the packet properly. It will increment the interface counter by 1, right? It will check the layer 2 header, layer 3 header, layer 4 header, all that detail, right? All the headers are properly formed or not, right? And after that, this packet is handled. This router will forward this packet towards the route processor, which is a processing engine inside this router, right? So your ingress stage. Then let's suppose on this router we have configured NAT as well, ACL as well, routing as well. Right now this router will check the routing table. If NAT is there, then this router needs to apply the NAT, network address translation. If we have configured the access control list, then this router will send this packet towards the ACL engine as well, right? Now let's suppose we have configured a few other things on this router, means now router will do all these other checks as well, right? Because you know when router used to receive a packet, there are around 27 checks but done by this particular router. There are the 27 checks available on the router, and all these checks done by this particular router on the packet. Okay, and after that, finally, after doing all these checks, finally, let me just write the last one. Let me make it like 6. It will basically do the egress stage processing. Egress stage also known as forwarding stage. Now, guys, when this router will do these particular 27 checks on the packet, means now router needs some time, right, to process that particular packet. Now, what used to happen, guys, in the router, let's suppose I'm taking a hypothetical number. Let's suppose this router took around 2 seconds to process this particular packet. And where the 1 second is taken by these particular 3 checks: routing table, net table, and ACL engine, because these are the major checks. In a router, let's suppose you have around 10,000 routes in your routing table. You have around 100 net rules. You have around 100 net rules in your router and you have around 3000 access control list. These are the major checks, guys. And let's suppose these major checks need around 1 second for this router to process this particular packet. And after that, after processing this packet, what this router will do, it has just forwarded this packet toward this server. Now this server responds with the next packet. What is the next packet here, guys? TCP SYN plus ACK. Now this TCP SYN plus ACK will also go through all these 27 checks. And after that, after going through all these 27 checks, because router is a stateless device, okay? It will forward this packet towards this PC. Now this PC send the next packet, which is an acknowledgement one. This acknowledgement, this third packet will also go through all these 27 checks. And after that, the next packet, you will see the HTTP GET request. This GET request will also take around 2 seconds because this packet will also go through with all these 27 checks. And after that, you will get HTTP response, and then you will now PC send some more data, and you will get some more data, right? And to guys download this file, let's suppose this router between this PC and this server, they have exchanged total of 200 packets. Means request and reply, all packet, they have exchanged 200 packets. Now to process this particular request, to download this particular file from this server completely by this PC, how many seconds this particular router needs? 400 seconds in total. Yes or no? Right? So means this PC needs around, or this router, this PC and server, they took around 400 seconds. So this router take around 400 seconds for processing this particular entire request. Okay. Now this is a behavior of this router, because router is a stateless device, guys. Now let me just show you the same behavior with the help of firewall. How firewall is going to do the processing. And guys, I will go specific with the Palo Alto firewall. Okay. So let me make my diagram again. The same diagram. I have the PC1 having IP address 10.1.1.70. I have my firewall. I have my one of the server here. This is a web server hosted on TCP/80. That server have IP address 10.2.2.101. This server again have a same file of 2 GB MP4 file .mp4. Now this firewall, this interface Ethernet 1 by 1, it is a part of outside zone. We have this interface, or what I can do, this interface is Ethernet 1 by 2. This is a part of inside zone. Okay, and let me just go in this way. And instead of this outside, let me put DMZ, because on my actual lab, this is DMZ. Okay, so I don't want to make any type of confusion here. This is DMZ, but it will apply for any zone. Okay, it doesn't matter at all. Now this interface have IP address 10.1.1.250, and this interface have IP address 10.2.2.250. Now let's try to see the process here again. Let me just make some space in like that. Now guys, you have to put your full attention, because now we will also understand here the packet processing stays in your Palo Alto firewall. So now this PC, what he will do, he will create a packet, and he will forward this packet towards this particular server. So what is the first packet? It's a TCP SYN request, right? Now in this TCP SYN request, this PC will create a packet like this, guys. Let me create a packet format here. 10.1.1.70 source IP address, 10.2.2.101 destination IP address, 1025 source port, and your port 80, which is the destination port. This is the packet created by this PC, and this packet he will forward towards this firewall. Now guys, remember one thing, when this packet is received by the firewall on Ethernet 1x2, and as soon as my firewall receive the packet, what it will do, now firewall do the packet processing according to the life of a packet in the Palo Alto firewall. TCP SYN processing. How TCP SYN request is processed by the firewall. So what it will do, my Palo Alto firewall going to process the packet at ingress stage. Now these stage you have to remember. After that, fellow lookup. This is the second stage. Then ingress stage, fellow lookup. Then your session setup, which is also known as silo path. Just remember, this is also known as silo path. Session setup is a silo path stage as well. Then we have a fourth one, which is fast path. Then we have a fifth one, which is forwarding stage. So this is how the TCP SYN packet is processed by the firewall. So what this firewall will do when he will receive this TCP SYN request, so this firewall will start processing the packet. In ingress stage, it will do the processing. Then it will send that packet towards the flow lookup, means it will do the session table lookup here, or flow table lookup. Both are same, okay? Because this is just a first packet, so there is no flow. So it will send that packet into silo path, which is session setup state. And guys, in your session setup state, let me just show you one more thing here. Oh, I have this diagram. I think this is not clear, right? Let me just open this then. So guys, are you able to see this particular diagram properly? Just confirm. And as you have seen here, Palo Alto 5 have a like ingress stage. Then we have a flow lookup. Then this is known as your fast path. Then we have a firewall session setup or silo path. Then we have a app ID. Then we have a content ID, because as I have mentioned, guys, your TCP SYN will not go through this app ID and content ID, because TCP SYN is not having any type of layer 7 data. Just remember, okay? It is not having any type of layer 7 data. Just remember. And after that, it will send that packet towards the forwarding stage. Now, guys, if you will just focus on the silo path. In silo path, you can see. In silo path, if you will see here, we have a forwarding lookup, means here it will do the lookup into the routing table. We have a net policy lookup, and we have a security policy lookup. This is also you can consider like your access control list. This is you can consider as a net. So this comes under the silo path. And as I have mentioned, guys, Any case of router, if your router is taking around 2 seconds in the full packet processing, your ACL, NAT and routing, this will take around 1 second, right? Now, let me just come back here. So guys, what used to happen? Now here the same logic is also applied. When this file receive this packet, it will process at ingress stage, then flow lookup. Flow is not found, then session setup, which is slow path. So means here it will do the routing table lookup, net policy lookup, and your security policy lookup. And if we have allowed that packet to the security policy, what will happen? Now it will create a session. What now it will create a session, and how it will create a session, what it generally used to do. This firewall extract the source IP from the packet, destination IP from the packet, source port from the packet, and destination port from the packet, which is 80. And guys, what is the layer 3 protocol number for TCP? Means it will include a layer 3 protocol number as well, which is for TCP it's 6. And we are receiving this particular packet on Ethernet 1x2, which is a part of inside zone, means it will include the source zone as well inside. And these are the 6 tuple information. What it will do, my Palo Alto firewall going to extract this 6 tuple information from this packet. And what it will do, it will store that particular information into the session table or into the flow table. Okay, what it will do, it will extract that information, it will store that information into the flow table or your session table. Now, and after that, it will store, then it will do the fast path processing, then forwarding, right? And your packet reaches into the forwarding stage. And your server, this packet reaches till the server. Now, when this server will respond, so you will send here the second packet, which is TCP send plus ECK. Now, when firewall receive this send plus ECK, what it will do? It will start processing at ingress stage. Then it will do the flow lookup, which is a second stage. But this time, because you know now, my firewall, because it has already stored that information, that 6 tuple information into the flow table. So this time it will found the detail of that particular flow. And because that detail is available into the flow table, so it will bypass this slow path and directly it will jump into the fast path. Means now what it will do, now this packet go into the third stage, which is fast path. Then the fourth one, which is forwarding stage. Because it's just a reply. Now this reply reached here. And after that, now this PC will send the next packet, which is the third one, TCP acknowledgement. Now this TCP ECK also it will process like ingress stage. Then flow lookup, in flow lookup, it will found the detail of this particular flow because this information is same. So it will bypass the slow path here. It will forward the packet to a fast path, then forwarding state will reach till this server. And after that, he will send the next packet, which is HTTP GET. Now HTTP GET processing, let me explain you. HTTP GET packet, it will start processing, it will process at ingress stage. Then it will do the flow lookup. And guys, this time flow is available. Session is available into the session table. So what it will do now, it will bypass your session setup with a slow path it will send this packet towards the fast path. But remember one thing, your HTTP GET has some data at layer 7. So this packet will go through the app ID. It will also go through the content ID. And after it will go through the forwarding stage. That's how it will process your HTTP GET request. Then we will get the response, then other packet, right? They will exchange all these things, and the remaining packet, they will follow this particular process. Now, just remember one thing. Let's suppose this PC, when he is trying to download this particular file of 2 GB from this server, and this firewall needs around 2 seconds for the packet processing, means TCP SYN is processed by the firewall in 2 seconds. Now, where 1 second is taken by this particular firewall at the silo path, because in silo path we have a major checks. So this particular silo path will take around 1 second. And guys, if you have observed, only the first packet we are sending through the silo path, and for the remaining subsequent request and reply packet, we are bypassing this particular silo path because session is created. Because session is created by the firewall, and your stateful inspection means what your firewall used to do. Firewall used to create a session, and it will store the information of the session into the session table or into the flow table, and it will bypass the silo path or session setup state completely to improve the performance of the firewall. And now guys, if they have exchanged around 200 packets to download this file, how much time this firewall will take to process the packet? For first packet, it will take around 1 second, and for 2 seconds, and for the remaining packet, he has just taken around 1 second, right? Means it took around 199 plus 2 equals to 201 second. And but about the router, if we had a router that time, router took around 400 seconds. Now see the difference in the processing. Now see the difference in the processing. So guys, your stateful inspection is a technology or it a mechanism which store the information of a session into the session table. And if my firewall store the information, because my firewall used to store the information of a session into the session table, and it will match each and every packet through the session table. And if there is a match, what used to do, my firewall used to bypass the silo part where we have a major checks like your net engine, your security policy engine, your routing engine, and there are few more things, and it will completely bypass that part. So what it used to do, it used to basically maintain the session table with the help of these 6 tuples. Source IP, destination IP, source port, destination port, layer 3 protocol number, and source zone. Okay. And it will basically, my firewall bypass the slow path for subsequent request and reply. So stateful inspection technology, what it used to do, it will improve the performance of the firewall. That is your stateful inspection. Guys, this particular technology is developed by a person. His name is Nirjuk. And when he has developed this technology is in 1993. And that time, that person, he was a part of Checkpoint firewalls. He was a tech engineer in Checkpoint. And during that time, he has just developed this particular mechanism. And guys, after 1994 onwards, all the other firewalls like your Cisco ASA and the other vendors, they have start using this particular technology. They have implemented the stateful inspection behavior into their firewalls. And guys, due to this particular technology of stateful inspection, it has just changed the it has completely changed the processing behavior of your firewalls. And guys, this Nirjuk, this person, he had just first worked with the NetScreen firewalls. NetScreen is nowadays known as Juniper Networks. He's a part of Juniper. He left Juniper, he has joined the Checkpoint, and basically during his Checkpoint journey, he has basically created or developed this stateful inspection technology. And after that basically what he left the Checkpoint and he has started his own company called Palo Alto Networks. And he has launched the Palo Alto Network firewalls first time in 2005. And guys, when he has launched this particular firewall in 2005, this was the only firewall who has a feature called App ID, who has a feature called antivirus protection, anti-spyware protection, vulnerability protection, all these features just within a same box. And guys, because you know, Palo Alto Networks or Palo Alto Firewall, they offer all these particular features just within the same box. That is the main reason of this particular Palo Alto Firewall. Like it is adopted by the organization rapidly and just within 3 years of time. In 2008, Palo Alto become the #1 firewall in the firewall industry. And from 2008 till today, Palo Alto Networks is leading the firewall industry. It is a leader in the firewall industry because of that reason only. Because you know why this firewall become popular? Because you know, guys, let's suppose if you go with the Cisco solution. So what they Cisco used to do, Cisco used to have a firewall called Cisco ASA. Cisco ASA will protect you from the layer 3 and layer 4 protection. Means you can able to control the traffic on the basis of source IP, destination IP, source port, and destination port. Now on this ASA, if you want to if you want a protection, if you want to add an antivirus protection, anti-spyware protection, and you need a vulnerability protection. For that, Cisco has a new firewall, new device called IPS. If you want a protection from malware, then Cisco have a new box called AMP. If you want a URL filtering, then Cisco have a new solution called WLC. Because you know, for each and every features, for each type of solution, Cisco have a all together a different box. And guys, if you will purchase different box, what they will cost you? You need a good network engineers who can manage all these devices, right? You have to procure all the license. You have to think about the life cycle of all these devices. There are so many things, right? And Palo Alto is offering all these features just within a same box. It was a just one box solution. So that is the main reason Palo Alto become very, very popular. And Palo Alto become, there is also one more reason called SP3 architecture. Palo Alto architecture is very, very unique. It's have a architecture like SP3, single pass software and parallel processing hardware, this type of architecture. And due to this architecture, Palo Alto become very, very popular device. Okay. So this is some information with regards to the stateful inspection and the history of your Palo Alto firewall, guys. And if you want more details, your Palo Alto firewall launched in 2005. And if you will see the Gartner reports here, Palo Alto is a leader in your firewall industry. And if you want to know more about the history, so here I have shared one link as well. If you will go into this link, you will get the details, how they have started and all the thing, right? They have launched in 2005. This device is managed by the Israeli American person called Nirzuk, former engineer from Checkpoint and Netskin Technologies, right? Then you will get all the details here regarding the history of this particular device. Okay. And Kalpesh, just wait for, I have not discussed the packet flow yet. Okay. Once I will discuss the packet flow, I will explain you in detail. Now. So guys, just tell me one thing. A stateful inspection is clear to everyone. Why, how your firewall is going to do the packet processing. Now, one more thing you have to remember here. Guys, just remember one more thing. When Palo Alto Firewall used to receive a packet, okay, because there is a little bit more information, or I can just explain here only. What used to happen when firewall used to receive a packet here on the ingress stage? Let's say this is the ingress stage for this particular packet which we have received from here. So what firewall used to do? Firewall used to create a flow key. And how it will create a flow key? It used to basically take out the source IP address, destination IP address, source port, and destination port. What it used to do, let me just write the information here. Or what I can do, let me just draw one small diagram again, one more time. So you will get properly because it become bit clumsy. Anyway, these are the things which you have to remember because you know in packet flow, I will take a reference of everything. And whatever I am discussing, because I am discussing because I want to explain you the packet flow in detail. Ten dot 1.1.70, 10.2.2.101 on TCP/80. This is your inside zone. This is my outside zone. This is my Ethernet 1x1 interface. This is my Ethernet 1x2 interface. Okay. Firewall receive a TCP SYN plus ACK, then your acknowledgement, and after that we will get the HTTP GET request. So this is the first packet TCP SYN. Then we have a second packet TCP SYN plus ACK coming from the server. Then firewall will send the TCP acknowledgement. And the fourth one, we have a HTTP GET request. And from here we will get the HTTP response. Okay, now. So what this firewall used to do when this PC will try to send any packet toward this server. So what it will do generally, this PC will create a packet like this. 10.1.1.70, then 10.2.2.101. This is the source IP, destination IP, source port is 1025 and destination port is 80. Now when this packet is received by the firewall, what firewall will do? Firewall basically in ingress state, what it will basically take out from this packet, it will take out the source IP address 10.1.1.70. It will take out the destination IP address, which is 10.2 2.2.101, source port 1025, destination port 80, source zone. Guys, how it will get the source zone? It will get the source zone because my firewall know he has received this packet on Ethernet 1x1 interface, right? He know the interface, and firewall also know this interface is a part of inside zone. So he will get the in source zone detail, and he will also get the layer 3 protocol number, because your TCP is a layer 3 protocol, right? So what is the layer 3 protocol number for TCP, which is 6? And what is the layer 3 protocol number, guys, for UDP traffic? Anyone know? What is the layer 3 protocol number for UDP? 17, right? So what it used to do now, this firewall is basically take out this information, and this information known as 6 tuple information of your session table. Session table, flow table, or connection table, all are same, guys. Okay, because flow table and session table is a name according to Palo Alto. Cisco use the term called flow. Cisco use the term called connection table. Okay, so do not confuse with that. Now this 6 tuple information, what my PaloAlto 5 going to do, it will basically run the MD5 hash. When we will run the hash on any type of data, what we will get the unique number here, we will get the unique value here. It's a combination of number, special characters, right? Okay, that's how we will get this particular unique value. This unique value known as flow key. This flow key is known as flow key number 1. And guys, this flow key, it is going to store into there is a database inside the Palo Alto is MongoDB database. This is the database which is available, or which is running inside the Palo Alto 5, because by end of the day, my Palo Alto 5 needs to store that data somewhere, right? For that, it needs a database. So it will store that information into a database called MongoDB database. Okay. And after that, what it will basically has created this flow key. And guys, using this flow key, this MD5 hash value, it will always do the lookup into the flow table or into the session table, or into the flow table. It will not check your session table or flow table on the basis of these values. It will always check on the basis of unique value, which is a flow key. And guys, this flow key is similar for all the packet which is coming from this server and going to which is coming only all the packet which is coming from this PC1 and going to this server. And now just tell me one thing. When this server send the reply, when this server send the TCP SYN plus ACK message, what is the packet format here for this ACK message? What is the source IP address? Source IP address is this 10.2.2.101. Destination IP address is 10.1.1.70. Source port is 80 and destination port is 1025. This is the packet he will basically send by this particular server towards the firewall. Now, if I will drive the 6 tuple information from that packet, then this 6 tuple information looks like this. Source IP address is 10.2.2.101. Destination IP address is 10.1.1.70. Source port is 80. Destination port is 1025. What is the source zone right now? What is the source zone, guys, for this particular reply packet? I am receiving this packet on Ethernet 1x2, which is a part of outside, means source zone is outside. And what is the layer 3 protocol number? It's TCP only, right? 6. So guys, in this particular reply packet, if you will see here one thing, your source zone information has been changed. And guys, remember one thing regarding this MD5 hash. If you will run the hash on this value, it will give you this number. If anything is changed on these values, what will happen? This number will change. This number will change, right? So guys, what used to happen now? On this particular packet also, firewall again run the MD5 hash. It run the MD5 hash, it will get the one value here now. Let's say this time he will get the value at the rate question mark PCD 34 PQ. Because you know this value, guys, this value here and this value is different. Why these two values are different? Because you know source zone tab, source zone field has been changed. So guys, remember one thing. If I'll go here into this packet flow, what it used to do in your Palo Alto firewall. Or before that, let me tell you one more thing, guys. Let me just tell you one more small thing here, and after that I'll just jump into that part. So guys, when this particular PC is a client here, right or not, and this server is this machine is a server here, and generally we have a two type of flow. We have a client to server flow, and we have a server to client flow, right? This client will send some traffic towards this server will reply, or he will send some packet towards this client. So we have a two type of flow generally, client to server and server to client. Now, what Palo Alto generally used to do, if you will see here, in your ingress stage, when your packet is complete the ingress stage, when it will do the firewall session lookup. In this session lookup, like because you know during this ingress state, it will extract your layer 3, layer 4 information. Means it will extract your source IP address, source port, destination IP address, destination port, your layer 3 protocol number, and your source zone detail. That information it will extract. And if you will see, they have mentioned here, if you will see here, they have mentioned this thing here as well. Ingress interface and zone lookup means firewall gets to know the ingress interface. It will do the zone lookup means it will get the source zone detail. Right now, my firewall is don't know the egress interface. Guys, tell me one thing. If we are receiving any traffic on a router, how router gets to know regarding the egress interface? Tell me. Anyone know how router used to get the egress interface? By doing the routing lookup? That's correct. By doing the routing lookup. Guys, in your Palo Alto firewall, this routing lookup is a part of slow path. Forwarding state here, it will do the lookup. So guys, because you know in ingress stage, it will basically create a client to server flow, and your flow key number 1, which is client to server, is created during the session lookup stage. Just remember that flow key is created and it will do the lookup on the session table on the basis of this flow key. And after that, when it will send this packet, because you know if flow is not there, then it will send the packet towards the forwarding stage. When your security allow the traffic, it will create a session, it will install the session. Means when it will get the egress interface details, means by looking into this egress interface, it will get the egress zone details as well, right? And if we have the details of egress zone, we can able to create the server to client flow as well, right? Because we know the source IP, we know the destination IP, we know the source port, we know the destination port, and we know the layer 3 protocol number. Only the missing part, which is the egress zone. Egress zone, when I will get, I can able to create a server to client flow as well. So guys, your actual session is created here and it will just got installed into the session table of the firewall. So your firewall have a two type of keys, guys, just remember always. And it has a always two flows, server to client and client to server, because you know in this particular client to server and server to flow, you can see these values are common, right? These values are common, only the difference is the zone, right? And this zone details for server to client, I will get from the silo path. Once I will get the detail of silo path, what will happen? I can able to create a server to client flow and client to server flow. Means I will create a two flow key, and both of these flow key I will store into my flow table. Now guys, whatever reply I will get from this server, which flow key will serve that request? This request is served by the server to client flow, and whatever packet this PC will send here, these requests is served by this server to server, particular client to server flow. And abhay MD5 value will change. That's why I have the different MD5 value there. Okay. Now, if I'll go into my firewall, let me just show you this part here quickly. Because if you will understand this thing, these are the some basic building blocks, guys. Okay. If you are able to get all these things, you can able to understand the firewall properly. If you are not able to get these details, you will not able to understand the things. If I run this console session all, this is the command to check the session detail. If I look for the session ID 2501, I have a two flow, client to server and server to client. And what is the difference into these flows? Source is same. Destination is also same. Okay, I think we are looking the source zone is this, source zone is outside. I was looking, I think, wrong packet. This is for ingress. Let me just go here. Okay, all are undecided application only. So what I can do, because you know, I'll go on my test machine here. Let me just create one session. Don't worry how this session I'm creating, because I have a running infrastructure right now. But we will build that infrastructure from scratch. But here just to explain the things. Okay, I will just put this IP address 10.2.2.101. This is a part of my DMZ zone, just remember. And if I'll have, I'm not sure if I'll have any security policy or not. Now I can see some of the traffic. Filter destination 10.2.2.101. No active session. Let me just look for another session. Let me just look for this one. I think I don't have that particular rule right now. So session ID 2502. You can see we have a two flows, client to server and server to client. 10.1.1.250. Source IP address. This is the destination IP. But you can see when reply is coming, destination IP has been changed, because you know NAT is happening, guys. Okay, I have configured the NAT as well, because I'm sending the request from my LAN towards the WAN. So that's why NAT is happening on this IP address. This is the public IP address. Okay. So don't worry about it. I'm going to explain that part as well. Okay. So it will always create two flows, server to client and client to server. This is the one thing which I want to explain. And our MD5 hash value will definitely change, as I have shown you. If anything you will modify, your MD5 value will always change. Just remember. Okay. So this is the one more thing which I wanted to explain with regards to your stateful inspection, guys. Whatever the lifetime and other things we will discuss in your future classes. Okay, I will not go in too much depth today. Now let me just see what I have. We have completed the stateful inspection. Firewall history is also done. Now let's try to understand some part with regards to the Palo Alto operating system. What is the operating system of your Palo Alto firewall? Okay, so we have a firewall called Palo Alto, and the operating system which is running into this particular hardware of your Palo Alto devices is known as PanOS. So what is PanOS? PanOS is the operating system of your Palo Alto firewall. Now, what Palo Alto did, there is a Linux called BSD Linux. And nowadays I can also see they are also using the CentOS Linux. So these are the two open source Linux operating system. These are the open source Linux operating system. So what they did on these Linux operating systems, they did some customization. Because you know, these are the open source operating system, you can able to change the programming. You can able to change the actual code of these devices. Means they did some customization on it. And after doing this customization, what they did, they have just added the PAN application. They have added the PAN application on top of this particular Linux platform. And the entire system become your PanOS. So your PanOS is a combination of BSD Linux or the customized version of BSD Linux plus PAN application. So guys, in the management plane of your Palo Alto firewall, management plane of your Palo Alto firewall is a Linux environment, just remember. And the data plane of your PanOS or your Palo Alto is the PAN application majorly. So this is all about the Palo Alto operating system. And guys, nowadays the latest Palo Alto operating system is your PanOS 11.x. Means nowadays they have a 11.x series. But guys, this series is not used by the peoples nowadays. Why? Because you know, this particular series is not stable. It is not a stable device, a stable operating system right now. In most of the organization, you will see the operating system or the PanOS version called 10.2.4. This is the most stable version as of today's date. We don't have any stable version on this particular series, but I will use this particular series only on my labs. Right now my firewall is on this particular 10.2.4 and I will upgrade this particular till 11.x. Okay, that's not a big deal. So this is the Palo Alto operating system, guys. It's a customized version of Linux. And guys, if I will run this command, so system software status, you can see these are the processes which are running inside your Palo Alto firewall. All these are the processes only, guys, which is these type of process you will see in the Linux device as well when you will run the top command there. Okay. You can also maybe try this command, show system resources. You will get all these particular processes which are running like batch dog. All these processes are there. These are the Linux processes only. Because the thing is, kernel of your Palo Alto operating system is based on the Linux. Okay. Kernel of your Palo Alto operating system is based on the Linux environment. Just remember. Okay. Now, apart from that, guys, Palo Alto Firewall offers 3 types of devices. We have a hardware box, which are the physical appliances. Palo Alto offers the virtual devices, VM series devices, and Palo Alto also offers a new type of devices, which is a CN series devices. These are the CN series devices. Guys, I'm audible properly? Can you just confirm on the chat? Yes, no? Okay, so guys, Palo Alto Firewall have a 3 type of devices. We have a hardware box. We have a physical platforms. Like hardware box is also known as physical appliance. In this physical appliance series, we have some series like, if I will write down the series, we have a very, very small series called Palo Alto 200 series. Recently, Palo Alto has introduced new series, which is a Palo Alto 400 series as well. Palo Alto have a PA 800 series. They have also launched a new series, which is Palo Alto 1400 series. Then previously, guys, we do had a Palo Alto 2000 series, but this series is end of life and end of sale. EOL and EOS. You will not see this PA 200 box nowadays. Palo Alto do have a PA 3000 series. This series is also end of life and end of sale. These are the first generation boxes, PA2 to PA2000, PA3000, right? Because these 300, 3000 and 2000 series become end of sale, end of life. Palo Alto have introduced new series, which is a PA 3200 series box. Recently, they have also introduced a new generation devices, which is a Palo Alto 3400 series box. Palo Alto do have a 5000 series, which is also end of sale, but still you will see this particular box in some data centers. Then we have a PA 5200 series. We have PA 5400 series. Then we have a Palo Alto 7000 series, and we have a Palo Alto 7400 series. So these are the some physical appliance we are having from the Palo Alto Firewall. And guys, these 2 series is for the small business units, where you have a less user count. Like let's say you have a just user between 0 to 100. If you have a less users, like if you just a small organization, you can go for these particular hardware boxes. If you are like, if your organization size is like you are some enterprise level customers, like you have a medium size organization, then you can go for PA 800, 1400 series, then 2000, 3000, 3200 and 3400 series. So these devices for the medium sized organizations, and your 5000 series, 50 to 54, 7000 and 7400 series for the data centers. So guys, these devices like PA200, 400 or 800, these devices you will see generally in your branch office. In your headquarters, you will see 3200 series, 3400 series. And in your data center, you will see the 5000 series, 5200, 54, or either the 7000 series or 7400 series. So these are the physical boxes we are having from Palo Alto. 1 minute. Go here. Now guys, in 200 series, we have a two type of box, PA220 and PA220R. This 220R is designed for areas where we have a humidity. If you have a more humidity, this particular device you have to deploy. We have a 800 series, 3200 series, 5200 series, 7000 series, right? In Panorama, we have a M200, M500, 600. Then we have some wildfire appliance as well, right? And if you will see the size of your 7000 series, very big, because these are the data center level devices. The throughput of these devices is very, very high. Apart from that, guys, Palo Alto do offers the VM series as well. In VM series, we have a 700 series, 500, 300, 100, 200, VM50. These are the VM Lite, right? These series and these VM devices where you have to deploy. You have to deploy if you have hosted your application into the virtual environment and you want to provide the protection there. Let's suppose you have hosted some application on AWS and you want same type of security posture on the AWS environment as well, like you have into your on-prem firewall. In that case, in AWS, what you have to deploy the VM series devices only. So for public cloud, for private cloud environment, or for the any type of virtual environment, we have to deploy the VM series devices. Like Palo Alto have a image or Palo Alto VM series, you can deploy on any public cloud like AWS, Azure, Google Cloud, Oracle, VMware, anywhere. Okay, you can also deploy this VM series into your private virtualized environment, like in your VMware, in your EXI environment, in your OpenStack or Red Hat OpenStack environment, where you can deploy these KVM type of files and other things. The main difference between your hardware series and virtual series is the throughput. Your hardware box is designed, they have a dedicated hardware which is basically designed for the Palo Alto boxes. So throughput of these devices is very, very high. And your VM series devices is don't have like too much high throughput. Okay, so the major difference is throughput only. There is a one person, Prano, he has asked one question: is physical device expensive than Juniper SRX? Man, there is, for that you have to check with the Palo Alto data sheet. Okay, I'm not sure about the pricing and other thing, but as per I know, Palo Alto devices are the expensive one. Okay. Now, apart from that, these series we do have a CN series devices as well. Guys, anyone know what is Kubernetes? What is Docker? We have a Docker, Kubernetes containers and other things, right? And guys, if you want, you can able to manage the Palo Alto infrastructure using the Docker and Kubernetes, these containerization or these microservices technology. For that, Palo Alto have created the CN series firewall. These are the cloud native firewalls. And guys, if you heard the name of nowadays cloud security, like anyone heard the name of Palo Alto Prisma solution? Like Cisco have launched one solution like SASE solution, right? All these particular technologies, they are using the CN series firewalls only, because nowadays people are deploying the firewall as a Kubernetes clusters with the help of Docker. What is the benefit you will get? If any of these firewalls got down due to any reason, there is a new device automatically bring up, means you can able to do the scale up and scale down these type of features. And guys, this is the future now. And like in future, in the cloud environment, you are going to see the cloud native devices only, CN series devices. You can able to put the CN series devices in this way, and you can able to control everything with the help of Kubernetes. So that's why, like, that is the main reason Kubernetes is the hot cake in the market nowadays. Okay. If you will go here into this link, if you will go into this link, guys, here you can able to check the all the latest series of this particular box. Like we have a 5400 series box. You can able to, like in 5400, we are looking right now 5410 series box. This is the app ID throughput, threat prevention throughput, connection per second, maximum session. These are the performance, other details, right? All these parameters we will consider when we are basically designing the solution, when we are purchasing the solution. Okay. So generally when we will purchase any box, we will check the data sheet. In 5400C, we have a 5420, 5430, 5440. Then we have a 3400 series, 3410, 20, 30, 40. Then we have a 7000 series box right here. You can go on the next one. So you will get all the box here. Then we have a 5400 series. Then we have 5200 C, 5280, 5260, 50, then 5220. Then we have 3200 series. So all these series you can basically check the Palo Alto data sheet and you can able to decide. Like when we have a Palo Alto 1400 series box, then 800 series box, then 400 series. Then we have a then here you can able to see 200 series, right? Then we have a VM series now. VM series with 2 virtual CPU and 4.5 GB of RAM. You will get the throughput of 3 Gbps, right? So you will see right nowadays, guys, we have a very powerful virtual machines as well. If I'll go here, like if you will deploy a VM, Palo Alto VM with 32 virtual CPU and 56 GB of RAM, you will get a 28 Gbps of throughput. It's huge nowadays. So guys, nowadays VM series device is also very powerful actually. You can see all the feature which is supported by these devices. Then we have a cloud native series here. This is your CN series box. And if you are very good with the cloud, because you know these CN series, it is just a beginning of that particular technology. So you will not get much resources to learn these technologies, because I have been in a Cisco project where I have deployed like Cisco ASA as a cloud native firewall. So I know architecture and other things. Okay, so that is the main reason I can able to explain. Otherwise, you cannot able to, like, people is not aware about these series. Okay, there are so many things, like you have to pretty good with the Ansible and all. You have to understand the entire architecture of the Kubernetes pod. So many things are there. Okay, because you know all the configuration we used to manage through the Ansible scripts actually. In case of Cisco SA, Palo Alto, I have not get a chance to work on the CN series boxes right now. Okay, so guys, these are the some hardware series, virtual series, and your cloud native series in your Palo Alto firewall. Yes, Manish, CN series devices we will use over the AWS cloud environment, Azure cloud environment, where we want to manage everything through the Kubernetes clusters or through the Kubernetes. Okay. Now guys, let's try to understand the most important topic of your today's class, which is SP3, single pass software and parallel processing hardware. And if you guys able to understand this architecture, and also let me tell you one thing, in every interview, in every organization, they are going to ask this particular question. If you are going for the Palo Alto interview, they will ask what is single pass software and parallel processing hardware, or what is the architecture of Palo Alto firewall. And if you are able to answer this architecture, you can able to, you will get the things properly. Okay, so before going into this particular architecture, guys, let me just explain you the multi-pass architecture. What do you understand with the multi-pass architecture? And if you know the multi-pass architecture, you can able to understand the single pass architecture. Okay. So in multipass architecture, what used to happen? Let's take an example of Cisco portfolio. Let's take an example of Cisco security product portfolio. So guys, tell me one thing. I am discussing the legacy design of Cisco. So what is the firewall solution we have from Cisco? What is the name of firewall we will be having from Cisco? Who offers the firewall solution? What is the name of firewall from Cisco? Cisco ASA. So we have a ASA firewall, right? It can protect you from, it will basically help you, or it will provide you the inspection using layer 3 and layer 4. I'm not talking about FTD and FMC for now. Then if you want a antivirus protection, anti-spyware protection, and vulnerability protection, what is the product I need to purchase from the Cisco? I have to purchase a product called IPS, intrusion prevention system. Cisco have a dedicated IPS device, IPS box, guys. Okay. If I want to configure URL filtering or proxy, if I want to implement a URL filtering proxy, for that, I want to purchase a solution called WSA from Cisco, which is also known as Iron Port. If I want to configure the file blocking policies, file protection, if I want to implement the wildfire type of features like the protection from the malwares and other things, for that I need to purchase a solution called AMP, advanced malware protection from Cisco. So let's take an example in this diagram. We have a Cisco ASA here. So let's suppose we have a Cisco ASA here. This is ASA firewall. We have a IPS here. We have a WSA here for proxy and URL filtering. And for antivirus, anti-spyware, DLP, for DLP, we have a advanced malware protection. For antivirus, anti-spyware and vulnerability, we have a IPS device. Okay, now tell me one thing. These are the peoples. These are the users. Now, if these users, they want to access, there's a one server here. Now, when they will access this server, they will forward this packet, right? They'll forward this packet. So this packet first go to WSA, that will go to AMP, then it will go to IPS, then it will go to Cisco ASA, and after that this packet going towards the server. When reply came, reply will also follow the same path. Yes, no. So guys, if in the path, if we have a multiple devices, like I have a WSA, I have a AMP, I have a IPS, and I have a ASA. When they will process the packet, now each device will use to start the packet processing from scratch or not? Each device will do the packet processing from the scratch, right? Like when WSC receive the packet, it will basically take out the layer 3, layer 4, layer 7 information. It will start the packet processing, right? Then it will basically again form the packet. It will forward this packet towards the next device, right? Now, in this path, because your packet is going through multiple devices, so this will add some delay or not? Yes, no, guys. If your packet will go through multiple devices, definitely there is a delay because each device needs to do the packet processing. So guys, now if I'll tell you the one thing, like if I will like tell you one more thing, like regarding the Cisco FTD. Anyone know what is Cisco FTD? Anyone have any idea about the FTD? How Cisco has created this product called FTD? What Cisco did? Cisco has just taken the ASA code. They have taken the ASA code, and guys, ASA engine is known as a Lena engine. inside the ASA, whatever the code or program which is running is known as Lena engine. So Cisco has taken this Lena engine, and on top of this Lena engine, they have added the snot engine. What is this snot engine? Snot is a next generation IPS engine. And on top of this snot engine, they have added some features of WSA. So they can able to do the SSL decryption. They can able to do the URL filtering and other things. And they have combined all of them, and they have make a product called FTD. So guys, do you think Cisco has done the programming of this box from scratch? No, they have just used the pre-programmed code. Means, because they have used here pre-programmed code here. So which means what used to happen when Cisco devices used to do the packet processing, first packet is processed by the ASA. When ASA will complete, it will forward the packet to Lena snot engine. Snot will do the IPS and other checks. Then will packet go for WSA for antivirus and other things. And after that, your packet came back, and your ASA finally forward the packet through the egress interface. Which means if I will tell you the serial processing, because it's not parallel, it's a serial processing. Means what used to happen? They say your ASA, which is a Lena engine. They say your URL filtering like WSA. Then we have a snot engine for IPS, and we have a like snot engine for antivirus. So you can say AMP engine for antivirus protection or malware protection. Okay. Now your packet coming first going into ASA. This ASA is going to process the packet, like it will extract layer 2, layer 3, all that information. It will do the port based mapping and other things, and will check the packet against your firewall policy. Packet came back, and now it is basically going the packet towards your URL filtering engine. Then going back, then it is coming back, then it is again going towards the IPS policy. Then it is going here, and it is going towards the antivirus or towards the AMP policies and other thing. And after that, your packet is going out. Means it's a serial processing, right? Means first firewall processing is happening, then URL filtering, then IPS, then antivirus. It's a serial processing, guys. So this is known as a multi-pass architecture, guys. And your Cisco FTD, your FortiGate firewall, and your checkpoint firewall, they are the UTM boxes, Unified Threat Management. Okay, these are they have an architecture of UTM type of architecture, and they will do the serial processing. Why they used to do the serial processing? Because they have not designed their code from scratch. They are using the pre-built code from some devices, and they are just adding these code on top of another code. If they did the programming from scratch of these devices, then only they can able to make the architecture differently, right? Because this particular coding is not done from scratch. So that is the main reason they will support the serial processing. It's a multi-pass architecture, guys. It's not a single pass architecture. Now in Palo Alto Firewall, let's try to see the Palo Alto Firewall architecture. So guys, first of all, you need to just remember one thing regarding the SP3. SP3 stand for single pass software and parallel processing hardware. This is the full form of your SP3. Single pass software and parallel processing hardware. And guys, your Palo Alto hardware is divided into two parts. We have a control plane, or this plane is known as management plane, and we have a data plane. DP means Palo Alto have divided its architecture into two planes, management plane and control plane. And guys, Palo Alto management plane has a dedicated role and responsibilities. Palo Alto data plane has a dedicated role and responsibilities. Now guys, tell me one thing. Let's suppose I have taken the CLI access of my firewall, or I have taken the graphical user interface GUI access of my firewall, and now I am doing the configuration on this firewall. This particular task is handled by the management plane of the firewall. And let's suppose there is a user who is connected with the Ethernet 1x1 interface of the Palo Alto firewall, which is a data port. And that whatever traffic is initiated by that particular user towards the firewall, this particular packet is processed by the data plane of your Palo Alto firewall. Means the request which is coming from your users servers is always handled by the data plane. Your management plane is designed for doing the management related tasks like your configuration management, your reporting, and your logging. These are the few tasks which is basically done by the management plane. All the tasks, all the traffic which is coming from the users, which is handled by the data plane of your Palo Alto firewall. So what Palo Alto did, because Palo Alto have basically divided its architecture into two planes, and you will get some benefit because of these particular thing, because if you have a separate management plane, means if you are doing any type of high level configuration, let's suppose you are just doing some configuration using some API calls, using some programming, or let's suppose your Palo Alto management interface is generating lots of traffic. Means if your Palo Alto management is generating lots of traffic, it will not impact your data plane. If somebody has launched any DDoS attack in your data plane, your management plane is safe. You can able to still log in into your management plane, and you can able to mitigate from that attack. So these type of benefits you will get due to this architecture. Now, this Palo Alto, what he did, he had just further divided its data plane into three another planes: networking processor, security processor, and content processor, or signature match processor, or your. So we have a network processor, we have a security processor, and we have a signature match processor or pattern match processor. And guys, these particular three processor, they have a dedicated resources. They have a dedicated RAM, dedicated CPU, and dedicated RAM and dedicated CPU basically. And they don't have any type of resource level dependency on each other. And if they don't have any type of resource level dependency, and guys, each of these processes, they have a dedicated task to do. They have a dedicated task to do basically. Okay, they have a dedicated task to do. And if you will see here, your networking related task is done by the networking processor. Your app ID, user ID, and content ID related task done by the content match processor. And your policy engine, your session setup, your silo path task, your fast path task is done by the security processor. And guys, I will give you the idea here. You can go here. You can see this is the actual architecture, guys. What Palo Alto did, it has a management plane, and the responsibility of management plane is for the configuration management, whatever the logging related tasks, whatever these logs is generated by the firewall, so this log management, and the reporting. Let's say you want to generate a report. So these tasks is a part of the management plane of the firewall. And guys, the management plane of the firewall, it has a dedicated CPU, dedicated RAM, and dedicated SSD, dedicated management interface, and dedicated console port. And it also has a dedicated HA1 interface. Means management plane provide the configuration, logging, reporting function on a separate processor, RAM, and hard disk. Means this particular resources is not shared with the data plane, guys. It has a dedicated sources, it has a dedicated jobs to do. Means if let's suppose all the resources is consumed by the data plane. If you are having a shared environment, if all the resources is consumed by the data plane, are your management plane able to perform well? No, because if they are sharing the resources, right? So because of that reason, they have basically segregated and they have provided the dedicated resources to these particular planes. And now this data plane is further divided into network processor, security processor, and signature match processor. And guys, your network processor is responsible for doing the flow control, which is also known as your session setup related task. Your MAC address lookup means your MAC table management. Your route lookup, your routing related task, your quality of service and net related task is done by the network processor. Then we have a security processor which will do app ID, user ID, URL filtering, policy match, your SSL and IPsec related task means SSL decryption, encryption, IPsec management, everything done by the security processor. Your compression and decompression is done by the security processor. And your signature match processor is responsible for your application identification and your content identification. Content identification means it includes your antivirus protection, anti-spyware protection, vulnerability protection, your URL filtering, your wildfire protection, your file protection. Everything comes under the signature match processor. Means your layer 7 packet processing or your layer 7 inspection done by the signature match processor or pattern match processor basically. And guys, all these particular processors, they also have a dedicated RAM, dedicated CPU. This has a dedicated RAM, dedicated CPU. This has a dedicated RAM, dedicated CPU. And this also have a dedicated RAM and dedicated CPU. Means they also not having any type of resource level dependency on each other. Means they can able to perform well. Guys, this is the parallel processing architecture, or this is the parallel processing hardware. In SP3, we have a two things, single pass software and parallel processing hardware. Means Palo Alto hardware can able to process the packet parallelly because it has designed in such a way. Your management plane and data plane is segregated, and also your data plane is further divided into three another planes. And all these three particular planes like your network processor, signature match processor, and your security processor, they have a dedicated task to do. And if you will see here, this is the like your signature match procedure, it has a RAM. Generally in signature match procedure, we need RAM basically majorly, okay? But it's a dedicated chip. We have a chip. This chip is also known as FPGA, field programmable gateway array. It has a dedicated core to basically do the things. Then we have security processor. Here we have a multi-core CPUs. We have a multi-core CPU means, do you know guys what is core? Let's suppose people has one person has only one hand, means he can able to perform one job. If he has a two hand, he can able to do two jobs. So multi-core means if your CPU has a 4 cores, means it can able to do 4 tasks at the same time. Okay. Then we have a network processor. Now, guys, this is these things, this information is for the peoples if you will read that details in the internet. Okay, now let me just explain you some advanced level details as well with regards to this particular SP3 architecture, and then only you can able to understand the things properly. So let me go here. I have a one diagram. Let me just pull that one. SP3 you will see somewhere here only. This is the one, I hope. Okay, so guys, now let me draw the actual architecture of your Palo Alto networks. how the hardware level what are the hardware component we are having, how the things looks like. Okay, so generally in your Palo Alto firewall we have a interface stack. These are the interface stack. Ethernet 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, and Ethernet 1 by 8. Let's suppose we have these 8 interfaces, and these interfaces, they are the copper port. Apart from these copper port, we do have a 4 SFP ports or 4 fiber port I can mention. We have a 4 fiber interfaces on the firewall, like Ethernet 1 by 9, Ethernet 1 by 10, Ethernet 1 by 11, and Ethernet 1 by 12. These are the 4 fiber ports I am having. Now guys, in this firewall, we have a 2 type of chip. We have a marble chip and we have a Petra chip. So guys, this marble chip will have a connectivity with all your copper ports. All your copper ports will have a connectivity with this particular marble chip. And your fiber ports, they have a connectivity with this Petra chip. Means your interface module. This particular module is known as a network interface module. These network interface module have a connectivity with these particular 2 chip. This chip is also known as switch fabric. Okay, now after that, in your Palo Alto Firewall, we have a one more chip. This chip name is Liger. So guys, if you are like dealing with low end boxes, then you have a Liger. In high end boxes, generally you will see the chip name called Tiger. And this particular Petra chip, it has a connectivity where this Marvel and Petra both has a connectivity with this particular. Then these are the guys, these are the high speed fiber links, and these links is known as joy links. And after that, this chip will have a connectivity with one more chip in your Palo Alto firewall. This chip is known as Oction chip. Both this Oction chip will have a connectivity with Liger and Tiger directly. And this particular chip is a Oction chip. This chip is also known as data plane CPU, which is DP CPU. And after that, this Oction chip will have a further connectivity with one more chip called Jaguar chip. And Oction and Jaguar, they have a connectivity with this high speed joy links. These are the fiber links. Now, your network processor, this particular Tiger and Liger chip is known as a network processor. And this particular processor is a FPGA, field programmable gateway array. And this processor acts as a session offloader. It is a session offloader. Okay. This Oction chip is a data plane CPU, and here you have a multi-core. It's a multi-core CPU. Here you will see multi-core CPU. And guys, these are the dedicated chip which is designed by the Intel for the Palo Alto firewalls. And we have a Jaguar chip. This Jaguar chip is also a FPGA, field programmable gateway array, and this chip is known as a signature match processor. Signature match processor or pattern match processor. Now, this Jaguar chip is responsible for doing your two type of task. This Jaguar chip is responsible doing your app ID and your content ID. And guys, content ID includes your URL filtering, your antivirus protection, anti-spyware protection, your vulnerability protection, your file policies. All these tasks means layer 7 inspection. Layer 7 inspection done by the Jaguar chip. Your Oction chip, which is a data plane CPU, it will process the packet according to the packet flow of Palo Alto or according to the life of a packet in PAN-OS. So means your actual packet processing is done by the Oction chip. And guys, this particular processor, as I mentioned, it's a session offloader. And guys, this particular processor you will not found on every Palo Alto hardware box. Maybe in some boxes you have the Oction chip only, and maybe in some boxes you have a Oction and Jaguar chip. But if I will talk about the high end boxes like your 3200 series box or your 5000 series box or your 7000 series box, they have this particular architecture. They have a Liger, Tiger, Oction, Jaguar, all these chips. And guys, your actual packet processing is done by the Oction chip. This particular processor come in a picture when session is offloaded by this Oction chip. Session offloaded means, tell me one thing, let's suppose we are receiving the packet for HTTPS, means we are receiving some SSL packet on my Palo Alto Firewall. And guys, SSL packet are the encrypted one, right or wrong? SSL packets are the encrypted one, right? So guys, because you know SSL packets are encrypted, so what used to happen? Can Palo Alto Firewall able to see the information if it is encrypted? It is not able to see. So what used to happen? If we want to allow the firewall to see the encrypted information, what we have to configure the SSL decryption? Let's suppose we have not configured the SSL decryption on the firewall. Means, and you know, when we receive the encrypted information, generally they used to encrypt your layer 7 information on the packet. So guys, if I will send the layer 7 information here and which is encrypted, are this Jaguar chip able to basically do the content identification or app identification for you? What do you will think? It's just a general question. Are this Jaguar chip able to do that? No, it is not possible, right? Because it's not able to read the information. So what this Jaguar chip used to, it will send one message to the Oction chip and it will said layer 7 processing completes. That particular thing it will mention. It will inform this message to this and this Oction chip, because this is the chip who will process the packet according to life of a packet, like ingress stage processing, your flow lookup, your slow path, your fast path, your forwarding, all these tasks done by here. Your app ID and content ID only done by the firewall at this particular place. So guys, what relevant for the session for layer 7 inspection is completed, what it used to do, my Oction chip used to offload that particular session to Liger and Tiger chip, because you know this Liger and Tiger chip, this network processor can able to read the layer 3 and layer 4 information, means it can able to do apply the net, it can able to understand the, it can able to do the route lookup, mac lookup, QoS, all these things. Means now why? Because you know now Oction chip is just offloading the load towards the Liger and Tiger chip. So your packet will go till here and reply will go like that. Your packet will not move till here and here, because we have offloaded. So your Liger and Tiger will only process the offloaded sessions. Just remember, it is just session offloader. Okay. And your Octeon chip will do the packet processing like your ingress stage processing, your flow lookup, your session setup, which is slow path, and your fast path, and your forwarding thing. Your forwarding is state processing, all these tasks done by the Octeon chip, and your app ID and content ID done by the Jaguar chip. And when this Octeon chip will do the will offload the load, then only your network processor come in a picture. Even though you can able to disable this session offloading, it's just a configurable feature. You can able to disable with the help of command. You can disable temporary or you can able to disable permanently. And this particular processor available into high-end boxes only. So guys, this is the actual architecture of your Palo Alto devices. And guys, because you know these are the dedicated hardware chips for doing, they are doing the dedicated task. So guys, do you have seen any type of resource level dependency when they are processing the packets? No. If there is no resource level dependency, means they can able to process the packet independently, right? Maybe let's suppose we have received 3 packets, packet number 1, packet number 2, packet number 3. Maybe packet number 1 is processed by this chip, maybe packet number 2 is processed by here, and packet 3 may be processing going on here. Means all these 3 packets, they are getting processed at the same time in a parallel way. This is the parallel processing, guys. So are you guys able now? I hope you got the parallel processing architecture of this Palo Alto firewall. This is the parallel processing architecture, guys. And one more thing you have to remember, because of that architecture, if you will see, let's suppose there is some processes which are running in your data plane, and these particular processes misbehaving. Generally, if any process is misbehaving in other devices, what they used to do, they used to recommend you can reboot the box. But in Palo Alto Firewall, you don't need to reboot the box. You can just reboot the data plane alone. If let's suppose there is some problem in your management plane, you can just reboot the management plane process. You don't need to reboot the entire box. So that is the benefit you will get with this particular parallel processing hardware architecture of your Palo Alto Firewall. Rahul, you can just revisit the recording one more time. You will get the things. Okay. Now, one more thing, guys, let me just show you the the one more thing I want to complete. And guys, for now, I'm not looking on the chat, okay? Because you know SP3, let me just complete. I have one more diagram. Where is that one? Not this one. Let me show you the actual diagram of your Palo Alto firewall 5000 series box, and you can able to get the exact packet processing detail or parallel processing hardware detail there. I have the diagram. Where is that one? This is the one. Let me just check here. No, this is also not the correct one. Let me go down. You will see with the name of SP3 only. Deployment modes, firewall feature. Nope, I'm not able to get it properly. Let me just. Let me see here, because here I can able to get it easily. The name is SP3 only for that as well. I'm lost somewhere, I'm not sure. Otherwise, I have a couple of other diagram as well. I can take the help of these diagrams as well, but on that diagram we can able to see the chip level information directly. That is the main reason I was looking for that. No, unfortunately I'm not able to see. Okay, cool. So what I can do, let me just open my this state 3 and 4. This is the one. Let's see. Just wait here. Okay, so guys, if you will see this particular hardware architecture, so this is the hardware architecture of 5000 series Palo Alto box. In this particular series, if you will see here, we have a switch fabric. We have a management plane. In this management plane, we have a dedicated RAM and CPU, and it's an Intel CPU, guys. Okay. Then we have a switch fabric where we have a SFP ports connected. These are your Marble and Petra chip. And after that, guys, what I have a network processor. Then here you can see I have a 3 oction chip. These are the 3 octane chip. They say your data plane DP0 CPU, data plane 1 CPU, and data plane 2 CPU. And I have a 2 signature match processor, 2 Jaguar chip. And guys, what used to happen? Your actual parallel processing architecture is applied for these type of hardware boxes, because if we have received, let's say we have received first packet, maybe let's say we have received 3 packets, packet number 1, 2, and 3. Maybe your packet number 1 is processed by this, packet number 2 may be processed by this data plane 1, and my packet number 3 is processed by DP2. Means all these packet is getting processed at the same time. And also, guys, because these are the multi-core CPU, means these CPU, they can do the packet processing basically, like they can able to process around 12 packets at the same time. And nowadays, as per my knowledge, in 50 to 100 series, we have a here 48 core of CPUs. And all these CPU, they can do the parallel processing at the same time, parallelly. So this is the parallel processing hardware architecture, guys. Okay, and let me just, in internet also, you will get like Palo Alto 5000 series. Let me just open. No, this is not the one. Palo Alto 5000 series architecture. Okay, now I got it actually. Let me just open this PDF. In this particular picture, you will see the details. Now, if you will see this picture, guys, this picture is visible properly to everyone. This is the actual hardware architecture of your Palo Alto 5000 series. Here we have a 3 data plane CPUs. These are your Octeon chip, and you can able to see the name of that chip as well. We have a network processor. We have a security processor. We have a switch fabric. This is your management plane. This is your signature match processor. And even though if I'll go over the internet, go into image section. Let me open a new tab. It is just trying to download again and again. I don't want to download it. Okay, so this is how the architecture look like for this particular device. And you can see this is the actual one. In this box, we have a Tiger as a network processor. We have a DP0, DP1, and DP2. This is your Octeon chip. And we have a signature match processor, which is Jaguar chip here. And we have a Marvel chip for copper port, and for SFP plus, we have a Petra chip. And what used to happen, how the packet flow, generally, let's say we have received a packet on Ethernet 1x1 interface. So this packet delivered to Marvel chip. Marvel chip will send this packet to Tiger chip, and Tiger will forward this packet towards the DP0 or towards the Octeon chip. Now this Octeon chip will do the packet processing, means your ingress stage processing, your flow lookup, your slow path, your fast path. All these tasks done by this particular engine. And if we need like fifth one, app ID, and your content ID is done by the Jaguar chip. And your forwarding again done by the data plane CPU. So after all that thing, what they will forward the packet back. Let's suppose egress is Ethernet 1x8, your packet came out like that. This is how the packet is processed. Okay, and always remember one thing, guys. This signature match processor is responsible for app ID and content ID, right? Now let me tell you one more thing, guys, because this is also most important part. This app ID related task done by the algorithm called DFA. And in Palo Alto, we have a AHO and DFA algorithm. So these are the two algorithms. AHO and DFA is responsible for app ID and content ID related task. But if I will tell you the architecture of any other box, okay? If you go down, let me just show you the architecture of 800 series box. In this 800 series box, you just have a Octeon chip. We have a management plane and we have a Octeon chip here, data plane only. And all your interfaces, they have a direct connectivity with this data plane. It not have any type of network processor. It is not having any type of Jaguar chip, signature match processor. So guys, at the hardware level, they just have a data plane CPU, which is Octeon chip. But at the software level, they have a segregation. Same thing apply to your VM series boxes. In VM series boxes, they don't have a dedicated hardware, right? So they have a segregation at the software level. Like they have a Jaguar, they have a like signature match processor, they have a signature match processor, security processor, and your network processor at the software level. Okay, just remember that part. All your hardware, it is not having this type of architecture. Just remember. Now let me see if anything is pending for with regards to SP3. One more time, I just wanted to check one more detail, guys. Okay, just give me 1 second. Legacy design we have already discussed, right? Okay, guys, this was the diagram which I was talking about. In a 5000 series box, you can see we have a security processor, and what is the chip name? Octeon chip. We have a network processor, we have a chip called Tiger. We have a signature match processor, we have a chip called Jaguar. And guys, here we have a multi-core CPU. You can see we have a 3 Octeon chip, and first chip is known as data plane 0, DP0, DP1 and DP2. And guys, all these particular data planes, they will do the load sharing with each other. This particular DP0 will handle all the brain related stuff, and these particular do the packet processing, and it will allocate these packets. There is a one algorithm called FPGA. There is a algorithm is running like first packet algorithm. I forget the like first packet processing app. Yeah, this is the algorithm called FPP. This algorithm is running here, and according to these algorithm, they will basically your DP0 will forward these packets for DP1 and DP2 for the packet processing, and all your complex tasks like your IPsec related packets, your SSL decryption related packets, all these type of packets is handled by the data plane 0. Like that, they will do the load sharing, and because all these three engines, they can able to work parallelly. So that's why Palo Alto architecture is parallel processing, or Palo Alto have the parallel processing architecture, guys. Now, let me just explain you the SP3 then. What is SP3? In SP3, guys, as I have mentioned, it's a combination of two things. Single pass software and parallel processing hardware. And so far, whatever we have discussed the parallel processing hardware. Now, let me tell you, what do you mean by the single pass software? Single pass software, guys, it is applicable in your content engine. When your packet reached at the content ID, means when your packet processing is happening at the Jaguar chip level. Here your actual single pass software architecture is applied. And guys, this content engine will do the few tasks, which is your antivirus protection, anti-spyware protection, vulnerability protection, URL filtering, file protection, wildfire, your user ID related tasks, all these tasks done by the content engine or content ID. Now, what used to happen basically in this content ID? If you will see in your signature match processor or in your Jaguar chip, we have the RAM, right? If you will see here in signature match processor, you can see we have a multiple RAM. We have a multiple RAM here, right? Now, what they used to do generally, when this packet is received by the Jaguar chip, so it will receive the layer 7 information from the packet. So this particular layer 7 information is loaded by the Jaguar chip into these particular memory location inside the RAM. It will load that information, and guys, in this content ID, because it has a signatures, right? It has a antivirus signatures, Just give me 1 second. Let me connect my charger. It has a anti-spyware signatures database. It has a URL filtering signatures, vulnerability signatures, right? URL filtering database, vulnerability signatures. It has a wildfire signatures, all these things. So what they used to do, because your packet, which is loaded in the RAM by the Jaguar chip, got processed by all these particular signatures just in one go. What they will load all these particular, this packet is loaded by these particular, there is a algorithm, right? As I have mentioned, there is an algorithm called DFA, right? DFA algorithm will do all the content related tasks, content ID related tasks done by the DFA algorithm. Nowadays, this DFA is replaced by the PScan. This is the algorithm which is running. This algorithm will load this particular packet, and against all these particular signature has been validated just in one go. Means at the same time all the validation happens, and whatever the results, they will get the final result, and your packet is back to the Octane chip. So means you can see all the processing here, all that processing is happening just in one go. It's just a streamlined processing. This is the single pass architecture. Means now your packet is directly will like processed by your content engine against all your signature database for virus, spyware, URL filtering, vulnerability, wildfire. Means all these scanning happen just in one go. In other devices, what used to happen? Let me just show you here. Let me just show you the multipass architecture. In multipass architecture, what was happening? Where is that? The multipass architecture diagram. Let me just open. In multipass architecture, if you have seen, it is just loading. Let's wait. In multipass architecture, what is happening? You can see here, this particular part. This part is repeating all the time. Right? First, your packet is loaded by the firewall engine. Then your packet is loaded by the URL filtering engine. Then your packet is loaded at the IPS engine. Then your packet is loaded at the AMP engine or antivirus policy engine, right? And they are doing the processing. But in your Palo Alto, what is happening? Your packet is loading inside the Jaguar chip, and all the URL filtering, everything is happening just in one go. That is the single pass software architecture. That is known as single pass software architecture, guys. Okay, that is your single pass software, guys. Okay, so guys, I'm just stopping here today. And what your packet flow and your initial access and other things we will discuss in your tomorrow class. Now let me just stop the recording.